Grade 7, week number 15, chapter number 14, a trip through geologic time. Lesson number 3, radioactive dating. Textbook page number 534 to 537. Welcome, dear students. I'm your physical science teacher, Mr. Dimish. In this lesson, we are going to learn what is radioactive decay and how to describe radioactive dating. Radioactive decay. Most elements usually do not change, but some elements can break down over time. These elements release particles and energy in a process called radioactive decay, and these elements are said to be radioactive. During radioactive decay, the atoms of one element break down to form atoms of another element. The half-life. The half-life of a radioactive element is the amount of time it takes for half of the radioactive atoms to decay. Here you can see the decay of a radioactive element, where the dark blue color represents amount of radioactive element remaining and the light color represents amount of new element formed. Have a look at the figure. After the first stage, 50% of the element changes as a new one and 50% of the previous element remains there. And when you come to the second stage, see the previous element remains only 25%, but the new element is now 75%. And then again it changes as 12.5 and 87.5. Finally you can see it's 6.5 and 93.5. So during each stage the half of the element changes as a new one and only the half remains. Radioactive elements occur naturally in igneous rocks. Scientists use the rate at which these elements decay to calculate the rock's age. As a radioactive element within the igneous rock decays, it changes into another element. So the composition of the rock changes slowly over time. The amount of the radioactive element decreases, but the amount of the new element increases. Determining absolute ages. The age of a sedimentary rock layer can be determined relative to the absolute age of an igneous intrusion or extrusion near the sedimentary rock. Geologists use radioactive dating to determine the absolute ages of rocks. Potassium-argon dating. Scientists often date rocks using potassium-40. This form of potassium decays to stable argon-40 and has a half-life of 1.3 billion years. Potassium-40 is useful in dating the most ancient rocks because of its long half-life. The next one is carbon-14 dating. Carbon-14 is a radioactive form of carbon. All plants and animals contain carbon, including some carbon-14. After An organism's death, the carbon 14 in the organism's body decays. It changes to stable nitrogen 14. To determine the age of a sample, scientists measure the amount of carbon 14 that is left in the organism's remains. Carbon 14 has been used to date fossils such as frozen mammoths and the skeletons of prehistoric humans. Carbon 14 has a half-life of only 5,730 years. For these reasons, it can be used to date fossils of rocks older than about 50,000 years. The most of carbon 14 left would be too small to measure accurately. Also, most rocks do not contain much carbon. What percentage of a radioactive element will be left after 3 half-lives? First, multiply half 3 times to determine what fraction of the element will remain. That means 1 by 8. You can convert this fraction to a percentage by setting up a proportion. That is 1 by 8 is equal to d percentage over 100%. To find the value of d, begin by cross multiplying as for any proportion. 1 times 100 is equal to 8 times d. That is d is equal to 100 divided by 8. That's equal to 12.5%. Thank you for listening and have a nice day.